So this is not about the regular class. Here I'm going to discuss the topics that are related to our CSIR net exam, gate exam, test exam. Okay. So here is the first topic is classification of elementary particles. So these are all class helpful to complete exam. So first topic is the classification of elementary particles. Elementary particles are divided into two types based on the spin. So if some elementary particles follow the spin integral multiple and some elementary particles are follow the spin half integral. So based on that, some particles, elementary particles like electrons, protons, neutrons, mesons, hadrons, baryons. So many elementary particles are there. In these elementary particles, some elementary particles follow the Bose-Einstein distribution. Some elementary particles are follow the Fermi-Dirac distribution statistics. So those who are following the Bose-Einstein statistics with a in integral multiple, then we can call that bosons. So those who are following the half integral multiple spin particles, then we can call the fermions. Fermions follow the Fermi-Dirac distribution law. Okay. The elementary particles are classified into two categories. One is bosons. Bosons are spin integral multiple. Okay. Next, fermions. These are the spin half integral. So the bosons follow Bose-Einstein distribution function, and fermions follow the Fermi-Dirac distribution function. Again, these bosons are classified into two categories. One part groups are is photons, graviton. So another part is these are very important. The mesons groups. So these are almost divided into three types. So one is pions. Pions are divided into again three types. These pions are pi plus, pi minus. So pi now. Next one is kaons. KAONS. So these are divided into four types: K plus, K minus, K naught is antibody. Okay. And next new meson. That is new now. So again, this Fermi answer. Those who are follow the Fermi-Dirac distribution law. So we can divide it or classified into two categories. One is baryons, depends upon their masses. So light particles and heavy particles are there. The light particles are leptons. Heavy particles, they are giving them the baryons. Light particles, we know the electrons are the light particles. Their anti-elements, tau muons, tau muons. These are the leptons, light weight particles. So these leptons are examples of the leptons, electrons, their antiparticles, and their antiparticles, tau, their antiparticles, and mu, and their antiparticles. Next, baryons. Okay, these baryons are classified into three categories. You know, the heaviest particles inside the atom is nucleus and proton, positive. Okay, between a proton, neutron, electron, right? Proton is plus antiparticles like that. Here, the neutron also there. Neutron and their antiparticles were going to write like this. And final classification is hyperons. Okay, hypercharged particles. So these are classified into the four categories. So this is the main classification in elementary particle physics. So final one is this one is lambda hyperon. This is denoted by this one. Okay, sigma hyperon. So the sigma is like that. Just remember these letters and their signs, antiparticles, neutron particles. Quasi particle. This is quasi hyperons. So these are represented quite different. Okay. Next final one is omega hyperon. Omega hyperons. This is denoted by like this. So these are the classification of the elementary particles based on their Bose-Einstein distribution law, Fermi-Dirac distribution law, and their spin values. So here I observed what I observed one most important difference between these two classes are there is no conservation law control the total number of bosons, whereas comes to in the fermions, fermions are the strictly conserved. Okay, next. So here I'm going to give some shortcut form classification. This is the original classification. This classification I was taken by DC style textbook. So that is very good. Elementary particle and nuclear particle physics. And David Griffith also. So the elementary particles are classified. We already know elementary particles are classified into two categories, right? The leptons. So this hadrons. So this is another classification shortcut. This is not original classification. So here, yes, if you have any doubt, just observe here the fermions, right? Hadrons. So the leptons, here I'm going to write these letters. You observe clearly this E, and I'm going to denote like this. This one is mu minus their antiparticle. This is tau they're antiparticle. Okay. Next, hadrons. The hadrons group of quarks. So the group of quarks, two type of groups are there. One is 2q group, another one is the 3q group. So these are the mesons. These 2q groups are mesons. These 3q groups are baryons. Next classification is the hadrons. Group of quarks. So these groups, we already know these are divided into two categories. So here I'm going to discuss the systematic classification. These are helpful CSIR GATE exams. Okay, two key groups. Here I'm going to denote like this Q and Q bar. Just remember this word. I'm going to discuss with you soon this each and every group and their properties. Three Q groups. Q, Q. Okay. So here Q bar is there. Try to recognize this one. Q, some bar. Here there is no bar. Okay. So these are mesons, right? Mesons. So the charge of this cube is plus 1 by 2. This charge of and this q bar is minus 1 by 2. The total charge is equal to 1 divided by 2 minus 1 divided by 2. That is equal to 0. Therefore, here the net spin is equal to the 0. The net spin is equal to the 0 here. Here the baryons are there. These are the baryons. Baryons. So variance I'm going to write like this: S1 equal to 1 divided by 2 and S2 is equal to 1 divided by 2 into S3 equal to 1 divided by 2. So first I'm going to add these two things, S1 plus S2 to S1 minus S2. Okay, this is one set. So here I got the 0, sorry, this is 1 comma 0, this is 1, this is 0. Okay, then I'm going to add this thing, third particle plus 1 divided by 2. Then we can get two different type of particles. Okay, so in case if you try to recognize this thing, this is baryons, 1 by 2 baryons. These are 3 by 2 baryons. Next category is the next I'm going to classify these mesons. Okay, hadrons are divided into two groups. One is 2q groups and 3q groups. So baryons we already discussed. These are the baryons and mesons. Okay, mesons. Q bar. So the spin equal to 0, mean net spin equal to 0 mesons. These mesons are I am going to classify it into three categories. So we all know mesons pi plus, pi 0, pi minus. Another class of category K plus, this is K0, and K minus, I'm not calling this minus bar, K bar, K bar 0, and nu. The Cations, neodymiums, and ions. These are the mesons. Okay. So if you observe here, how many mesons are there? How many mesons, elementary particles are there? These are the four. And remind these three. These were the eight. These are we can call octa particles. Okay, total 8 number of particles, right? Okay. The hadrons are basically divided into one is mesons and baryons. So, what are the spin 1 by 2 baryons, spin 3 by 2 baryons? Okay. Spin 1 divided by 2 baryons. Those are P, N in proton neutron, lambda, sigma particles, and these are the cascadic particles. Word is quite unique. So we never know this particle. So this is sigma, right? Sorry, lambda. These are the sigma particles. So these are the particles, RD particles. Okay, next spin 3 by 2 particles. Okay, so delta plus plus delta plus delta naught delta minus sigma star plus sigma star 0 sigma star minus. These are also spin 3 by 2 particles. And this benzene structure like particles, these are the cascadic particles. 0, okay, star minus. And final one is this one is omega. These are the delta particles. These are the sigma particles. These are the cascadic particles. These are the omega. So the overall elementary particle classification here I'm going to write like this. the final classification. These are all classifications are helpful. So leptons, right? Leptons, first leptons. Lightweight particle electrons, and this the anti-elementary particle of electron. This is muon. They're antiparticles. Tau, they're antiparticles. Okay? This is the final classification you want to remember in case if you try to solve elementary particle problems. CSIR GateNet, just example. Hadrons. Hadrons are the two groups. We know one is 2q, another one is 3q groups. These are mesons, spin equal to 0, and these are the baryons. Okay, so there's some spin is there. Is equal to 1, 0 plus 1 by 2. You can get some combination after that. So these mesons are these are the final mesons. Pi plus, pi 0, pi minus, and k plus, k0. This is one set of group. This is another set of group. Okay, this is another set of group. So another classification like this. So we can arrange after studying the elementary particles like this in shortcut forms. So these are not complicated things. Okay, this is the final classification. Okay, so the spin 1 by 2 particles, proton and neutron, and this one, and sigma plus, sigma 0, sigma I. So these CSI particles like this, 1, 2, 3, 4, 4 categories row remaining in 3 by 2 particles. Okay, this is the final classification. So you want to remember this table and each and every time. Then you can get answer easily. So after that you need to study some basics things. Then you can remember that these leptons and baryons, hyperons rules. Torque plus. Okay, please adjust, my handwriting is not that much good. Okay, these are the final the classifications. Okay, now I'm going to discuss one by one property of these elementary particles. So the first one is the conservation laws. So these are the main classification. So why I am discussing this many classification. So first, this is textbooks classification. So in each and every textbook, this classification is there. From this classification, you can arrange these elementary particles like this. So by solving the CSR net and gate problems, we need to arrange like this. Then we need to know what are the leptons, hadrons, and a group of quarks, and two Q group and three Q groups. So there corresponding components. Okay, this is the main classification. This is easy, right? The elementary particles are leptons, hadrons. Most of the questions asked by these leptons and hadrons, elementary particles. Okay. The first, here we are going to discuss the first thing is the uh, conservation laws.